Prove by mathematical induction that 7n minus 1 is divisible by 6. Now this time, guys, before we start, it doesn't actually give us any restriction for n. Usually they give us a little restriction for n. For example, they say n is greater or equal to 1. That's what they did for the previous two questions. But this one, they didn't state that. So we can't actually start just quite yet. So we have to make our own restriction. Okay, we can't just sub in any number for part 1. So step 1, it says prove it is true for n equals to 1. The reason why I chose 1 is because it's divisible by 6. If it's divisible by 6, it must be a positive number. It cannot be negative. Negative 6 is, we can't say it's divisible by 6 because it's a negative number. Make sure, guys, always keep this in mind. When it says divisible by some number, in this case 6, it must be a positive number. Make sure it's not negative. So I want to find the smallest number that makes this non-negative. Okay, so we'll start from 0, okay? We'll start 0 and we'll try to sub in some other numbers and see if they make negative or positive numbers. So if I put in 0, 7 to the power of 0 minus 1, 7 to the power of 0 is 1. 1 minus 1 is 0, okay? Which is not divisible by 6. 0, we can't say it's divisible by any number. So 0 is not right. Now if I sub in 1, whoops, sorry, why did I put an equal to sign? 7 to the power of 1 is 7, minus 1 is 6. This is actually okay because it's 6, which is a positive number, and we know that it's divisible by 6. But we'll keep trying because this might be a coincidence. So I'll try maybe like the next two numbers again, and if those satisfy this, then we'll just do our step 1, our usual way of doing step 1. So let's do power of 2 and see if this works. 7 squared is 49, and minus 1 is simply 48. And we know that this is divisible by 6 as well, isn't it? So this is also true. Okay, I'm assuming the next few numbers will also be divisible by 6 and definitely positive. I'm pretty sure that 7 to the power of 3 is also quite big, it's positive, and you subtract 1 and you can check that it's divisible by 6 as well. I won't go any further than that, but for this kind of question, it's important for you to understand this kind of idea. Okay, and it's a good idea to put these in your working before you start off, just to show you can identify the restriction by yourself, even though it doesn't tell you in the question. Make sure you understand what I just said there. Make sure you don't skip this because this is very, very important. So as we know, n equals to 1. When n equals to 1, that was the first non-negative, non-zero number. It was the first positive number, wasn't it? So that's why I'm going to start with n equals to 1. Alright, so let's prove it is true for n equals to 1. Sub in n equals to 1. I've already done that here, but you can show again 6, which is divisible by 6. So therefore it is true for n equals to 1. Now step 2, just our assumption. Assume it is true for n equals to k. Sub it in, sub n equals to k, and make sure it is divisible by 6. We want to show that 7 to the power of k minus 1 is a multiple of 6, so it must be equal to 6 times some number m. Alright, and make sure m is an integer. That's my assumption there, and now let's go to step 3. Okay, there's my assumption. We'll use that soon in step 3. It says prove it is true for n equals to k plus 1. So this time, replace n with k plus 1, just like this. So I have 7 to the power of k plus 1. And the 7k plus 1 minus 1 must also be a multiple of 6, or is divisible by 6. So therefore, I'm going to make it 6 times some number, p in this case, and it must be an integer. So p is some integer. Alright, so that's my step 3 that I'm going to be proving. So let's get started with the proof. So you know that 7k plus 1 minus 1, again I'm going to separate this one to something like this. So you can see that 7 to the power of k plus 1 is the same as 7 to the power of 1 times 7 to the power of k, right? We can separate it out using our index laws. And then minus 1, I'm just going to separate that one as well into negative 7 plus 6. We know that negative 7 plus 6 is negative 1, right? So that's what I did there. And you'll see why I did that in a second, because I'm just trying to be a little bit more smart in attempting this question. So have a look at what I'm doing next. I'm going to factorize this part by 7. Okay, so if I factorize it by 7, I'll have 7k minus 1 left over. And you'll see why I'm doing that. Have a look at our assumption. Our assumption, I've used 7k minus 1 equals to 6m. That is equal to this, isn't it? So therefore I can replace this with our assumption, 6m. Okay, so that's all I did there. So now I've done that, that's equal to that. I can factorize by 6 because 6 is common in both terms. So you take out 6 and you'll have 7m plus 1 left over, which is divisible by 6. Now guys, stop for a moment. Make sure you understand this as well. This might not be the question that will be in your exam. If you do happen to get a similar question in your exam and you're trying to show you're working that it's divisible by some number, in this case 6, make sure this number is an integer, okay? Because it must be an integer. Remember I told you that p must be an integer in order to be divisible by 6, in order for 6p to be divisible by 6. So if this is not an integer, you can't say that it's divisible by 6, okay? So what I mean by integer is, say for example, because I know that m is going to be 1, 2, or 3, or 4, I'm sure that this is going to be an integer, right? Because say for example, if m is 3, 7 times 3 plus 1, okay? That's 21 plus 1, which is 22. That's definitely an integer, isn't it? So as long as m is an integer, this expression here will definitely be an integer. But say for example, you came out with some solution of 6 and maybe you had some number, I don't know, I'm just like writing anything, say 2, something like that. In that case, we're not sure if this is an integer or not. We can't say that that's an integer. Because say for example, if this is odd, say 15, 15 divided by 2 is not going to be an integer, is it? So therefore, in this kind of case, we can't say that that's an integer and we can't say that it's divisible by 6. So I want you to always check your working and see whether this is an integer or not, okay? So that's also very, very important, guys. You can't just factorize by 6 and then say it's divisible by 6. Okay, so just keep that in mind. So this is definitely an integer. We know that it's divisible by 6. So therefore, if the statement is true for n equals to k, which was our assumption, it is true for n equals to k plus 1. Hence, it is true for all integers, n is greater or equal to 1. This is something we found, wasn't it? By induction.